Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Hello everyone, welcome to another session of Oxygen Talk brought to you by the Oxygen Alliance. Today on the 28th of November 2024, let me welcome you to this session. My name is Foster Sentala and I'm a biomedical engineer for the Oxygen Alliance, and I'll be your host today. I would also like to know wherever you're joining us from, so please type your name and your location in the chat so that we know where you're joining us from. If this is your first time joining our webinars, may you also please type your email in the chat so that we can add you to our emailing list. Today, we have a very insightful session where I will be discussing anesthesia gas scavenging systems as used with anesthesia machines. So we are joined by distinguished speakers who are engineers from the Oxygen Alliance and the OpenO2. So we have biomedical engineer Victor Mzembe and Ethel Utumbe, who will be our speakers for today's session. If you have any questions after the presentation, we'll grant you a chance to ask. So please take notes and keep your questions for the end of the presentation. Today, I will also, as Oxygen Alliance, we'll be carrying out a survey whereby we'll be getting feedback from how our webinars have been throughout the year 2024, and also how you, our audience, would like to have our webinars done in 2025. So please hang in there. At the end of this webinar, we'll carry out the survey. So please stay up to the end so that you can also fill out the forms that will be distributed. I have also an exciting news today that the BME Konza app by the Oxygen Alliance, the long-awaited BME Konza app, is now officially out. The app was launched last week on the 21st of November in Tanzania, and it's now out on the Play Store. So you can just search it out and install in your devices, and this app will help you a lot as you're doing your work as biomedical engineers and biomedical technicians. At the end of the presentation, I'll also share you a QR code that you can easily scan to install the app in your devices. So without wasting much of the time, let me now hand you over to our speakers of today as they kickstart the presentation. Over to you, our engineers.
Thank you very much, Foster. Welcome, everyone. My name is Ethel Utumbe, the biomedical engineer under the OpenO2 initiative. So today we are going to talk about the anesthetic gas scavenging systems. So I'm going to present the first part, and my colleague Victor is going to finish presenting the last part. So by the end of this presentation, we need to understand the what scavenging systems are, their types, their components, how it works, system selection and the installation considerations, how to troubleshoot in case something is wrong, and also how to manage all the programs. So the scavenging systems, like I've already said, these are systems that are found in the hospital. They collect and save and dispose the waste anesthetic gases in the operating room or the recovery area. So we need to understand what are the anesthetic gases. So the anesthetic gases, these are chemical gases that are used to keep patients conscious during the surgery or the medical procedures. But when we are administering the anesthetic gases, there's some leakages. So these leakages are called the waste anesthetic gases. And also this system is linked to the anesthesia machine. So anesthesia machine, this is the machine that is used to deliver anesthetic gases during the surgery in order to maintain the patient's level of consciousness. But during this procedure, not all gases that are administered to the patient are absorbed by the patient. A certain portion is exhaled and it escapes from the system to it accepts the system as the waste anesthetic gas. So this waste anesthetic gas poses a risk to the healthy workers, and also it poses a risk to the environment. So that's where the scavenging system comes in. The scavenging system is there to, like I've already said, to collect the waste anesthetic gases and then dispose them safely to the environment in order to protect the healthy workers from the possible healthy effects that can come due to the waste anesthetic gases. So this is how the system is connected from the anesthetic machine to the scavenging system. As you can see, there is this whole diagram is explaining about the anesthesia machine, and then as you can see, below is written to the scavenger. I mean to say that's when we connect our scavenging system. So we are considering it. We are continuing to another slide. So we need to know types of anesthetic gases. So there are two types of anesthetic gases. We have gaseous anesthetic agents. These are gases at room temperature, and they can be used alone or in combination with the volatile anesthetics, nitrous oxide. And we also have volatile anesthetic gases. So these are liquids at room temperature and the pressure, but can be vaporized to deliver them as inhaled gases during the anesthesia. So like I've already said, the nitrous oxide can combine with this volatile anesthesia machine. Sometimes the nitrous oxide cannot be used alone. So continuing to the sources of waste anesthetic gases, the question can be, where are the waste anesthetic gases coming from in the anesthesia machine? So the waste anesthetic gases comes from spillage when filling anesthesia gas into the vaporizer, in case baby made a mistake and then there's a spillage that is considered as a waste anesthetic gas. Let's say there's some loose connections between the tubing and the device. For example, maybe the APO valve, the O-ring, and the T-piece. So when that anesthetic gas escapes, it is called a waste anesthetic gas. And sometimes it can be from the patient when they exhale gases that were not metabolized and are not properly scavenged. So the gas that has been exhaled from the patient, that is a waste anesthetic gas. Also, sometimes the face mask and the seals tightly fitting, that means there will be some leakages. Those leakages will be the waste anesthetic gas. Sometimes it can be that maybe there was a procedure going on in the OR, in the operating room, and then maybe people forgot to turn off the fresh gas flow of the vapor. So when that anesthetic gas escapes from the anesthesia machine into the OR, the environment, that will be the waste anesthetic gas. So there, like I've already said, there are so many effects that can be there because of these waste anesthetic gases. So these effects can be can come to the workers that are the healthcare workers that are working in the OR or the recovery room. So there are short-term effects and the long-term effects. So on the long-term effects, on the short-term effects, some can experience a headache, some can feel can have difficulties in judgment and coordination, and some can feel nauseous. So these are the short-term effects. So let's move on to the long-term effects. So on the long-term effects, we have miscarriages in females. Let's say a pregnant woman was working in the OR, So once this female inhales these waste anesthetic gases can lead to miscarriages, and there's also reduced fertility. The waste anesthetic gases can reduce the fertility, and also there's some birth defects. Like I've already explained in the first point that when a pregnant woman is working in the operation room, so the person has inhaled the waste anesthetic gas, this can lead to the birth defects to the child that that woman is carrying. And also it can lead to cancer, there is liver and kidney disease, and also neurological diseases. So moving on to the regulatory guidelines and safety standards. So there are two bodies that are there that explain more on how to regulate the standards of the anesthesia gases. So the first body, we have the Control of Substance Hazardous of Health, COSHH in United Kingdom, and also we have National Institute of Occupational Health, of Occupational Safety and Health in United States, which is abbreviated as NIOSH. So these two bodies, they explain more on the maximum acceptable levels to which workers are exposed based on an 8-hour time weight average. Mean to say like the average, mean to say the maximum acceptable levels to a worker, a healthy worker that is working in an OR should be exposed to these waste anesthetic gases. So let's see the standards. So these standards differ. They differ from the United States of America and United Kingdom. So as you can see, the first part, the nitrous oxide, is 25 ppm. So ppm in this case, it's parts per million. And also, as you can see, United Kingdom is 100 ppm. If rain and some other gases in the United States, it's 2 ppm. Let's say the hydrogenated gases, the hydrogenated agents in the United States, they are 2 ppm, but in United Kingdom, they differ, where 3 hydrogenated gases, they are 50 ppm, and the sevoflurane is 20 ppm, and halothane is 10 ppm. While the combination of hydrogenated anesthetic gases and the nitrous oxide is 0.5 ppm. So let's move on to the to how the scavenging system works. So as you can see on the diagram, there is gas collection assembly. So the waste anesthetic gases comes from the breathing circuit, and then they go through the ventilator lift valve, and some waste anesthetic gas can come and enter into the APO valve. The APO stands for the adjustable pressure limiting valve. So then it transfers, like there's a tube that that takes these waste anesthetic gases into the scavenging interface. So this scavenging interface can be open or closed, and then after passing through the scavenging interface, and then it goes through the gas disposal assembly, which directs it to the gas disposal assembly. So on the gas disposal assembly, it can either be vacuum, which is active, or can be passive. So let's look into these components one by one. So the gas collection assembly, this simply captures the excess anesthetic gas, like I've said. It can be the APL and the ventilator valve, like the way it's shown on the diagram on the previous slide. So this captures the excess anesthetic gas in the OR, and then it delivers it to the transferring tube. So the transferring tube, it conveys these waste anesthetic gases to the interface. So on the interface, this interface was designed to protect the patient's lungs from the excessive positive and negative scavenging system pressure. So the system can experience some negative and positive pressure. So this interface was designed to protect the patients from these pressures. So it also provides a reservoir capacity to help to cope with peak expiratory flows from the patient circuit. So this scavenging interface can be open or closed, like I said on the previous slide. So let's move on to other components. So we have gas disposal assembly tubing, so which is just taking the waste anesthetic gases from the interface to the gas disposal assembly. It's just a tubing that is directing it from the scavenging interface to the gas disposal system. So like I said, the gas disposal system can be active or passive. So this gas disposal system, that's where the waste anesthetic gases is discharged safely to the atmosphere. Like I've already said, the scavenging system, it collects the waste anesthetic gas, and then after collecting it, it disposes it off to the environment safely. So let's move on. So let's, like I've already said before, we have two types of scavenging interface, which is open and closed scavenging interface. So let's start by explaining the closed scavenging interface. So the closed scavenging interface, as you can see on the diagram, there is waste anesthetic gas coming from the breathing circuit, and then we have a reservoir, positive leaf valve, negative leaf valve, and we have evacuation at the end. So this interface is sealed from the atmosphere with the positive and negative pressure leaf valves, like I've already said. So the positive leaf valve is there to prevent overpressurization in the breathing circuit, and also the negative leaf valve is there to prevent the excess section. And most of the disposal system that uses this closed scavenging interface is the passive system. So moving on to the open scavenging interface. So the open scavenging interface, like I've already said, it's open to the atmosphere. So it prevents pressure building up from the excessive sanction. So it uses an open reservoir. As you can see, the air can enter and then can leave. It's open to the atmosphere, and also it has an air brake between it. So it's providing an air brake, as you can see, and the air brake, like I've already said, is there to prevent the pressure building up and the excessive sanction. So, and then as you can see, it's connected to the vacuum. So this open scavenging interface is mainly used in the active system. So let's move on. So we have types of scavenging systems. So like I've said, active and passive, these are types of disposal systems. So on the active, we have a piped central vacuum. So a piped central vacuum, that will be at the end of the scavenging system. A disposal system, and also can be active duct system. So on the passive side, we can have piping direct to the atmosphere. You can also use adsorption canisters, and you can also use loom ventilation systems. Let's move on to these types in details. So the active system, this normally uses a mechanical vacuum to actively draw the waste anesthetic gases out of the system. So the vacuum source mainly is used to drive around these gases in the system and then directs them to a disposal location. So there are components that are there on the active system. So we have a vacuum source. So a vacuum source can be a vacuum pump, fan, or fan to pull the waste gases. So the operating pressures is within 0.5 centimeters of water to 5 centimeters of water. And we also have adjustable flow. So this adjustable flow is there to regulate the vacuum flow rate, so to minimize excessive section. So it is in an order of 8 liters per minute. And we also have a pressure relief mechanism. So it can be negative or positive. Like I've already said, the positive prevents overpressurization in the breathing circuit, and the negative relief valve prevents the excessive suction. So let's go to the next slide. So this is an example of an active scavenging system. So like I've already explained that the scavenging interface. It can use a closed scavenging interface or an open scavenging interface. So in the closed scavenging interface, it has a positive pressure relief valve. So as you can see, we have a positive pressure relief valve and a negative relief valve. And also we have our system connected to the hospital vacuum system. We have adjustable knob, which will prevent the excessive suction. And also we have a reservoir bag. So mainly, the positive pressure relief valve will open when the waste anesthetic gases are high at the collecting tube, like in the intake port for the waste gases and the anesthesia ventilator. This will open when there's high pressure. The positive pressure relief valve will open, letting in the waste anesthetic gases into the reservoir bag. And when the pressure at this hospital vacuum system is below 0.5, it's 0.5 milliliters of water, it's going to take the waste anesthetic gases from the reservoir bag to the hospital vacuum system. So let's move on to the advantages and disadvantages of the system. So the active scavenging system, its many advantages that it's highly efficient in removing the waste anesthetic gases since it uses vacuum. So mainly this system is commonly used in most of the hospitals. So the disadvantages is that it has high installation and maintenance cost. As I've already said, you need a vacuum source. So for you to install the scavenging system, that means you also need to install the vacuum source. So during the maintenance, let's say the planned preventive maintenance, that means you also have to check the whole system. You also, when you're checking the whole system, you also have to check the vacuum. And there's also a risk of excessive suction in case the adjustable knob is not working properly. There can be excessive suction, and also complex design because it is involving the vacuum at the end of the system. So let's move on to passive scavenging system. So passive scavenging system, mainly it relies on the when a patient exhales, it helps to drive these gases to the disposal. So it relies on the natural gases, often driven by the patient's exhalation or the pressure from the anesthesia machine, to direct the waste gases to the disposal location. So mainly it depends on the patient's exhalation and the pressure from the anesthesia machine. So on that diagram that was explaining types of disposal systems, I explained that it can either be throwing through the system into an insulating ventilation system or to the atmosphere via the exhaust. That means the gases came from the gas collecting tube, like I've already explained before, and then it goes through the transfer tubing, to the scavenging interface, and then to direct to the atmosphere. And also some of the passive scavenging systems, they use longer tubings for gas disposal. So they simply use the tubings for gas disposal. And also I have absorption device, e.g. charcoal canisters. So these charcoal canisters absorb the hydrated gases, but they don't absorb the nitrous oxide. So mainly this system is used for the halogenated gases. So let's move on to the next slide. So as you can see, this is a type of a passive scavenging system. The blue thing is the blue canister. That's the canister that I'm talking about. It contains the charcoal, which is there to absorb the halogenated agents. So when I was explaining, I explained types of anesthetic gases. So I explained about the hydrated agents, which can be the halophane. That's one of the hydrated agents. So let's move to its advantages and disadvantages. So it's simple to design and easy to maintain. Like I've already said, this some of these system only uses tubings. That means it's simple to design and also to maintain. And there's no risk of excessive suction or negative pressure because this system is not using the vacuum. So there will not be any risk of excessive suction or the negative pressure. So the disadvantage is it can lead to environmental contamination if not disposed properly. Like I already said, some of the system only use tubings and then they dispose it direct to the atmosphere. So if these waste anesthetic gases they're not disposed properly, they can lead to environmental contamination. And it is also less efficient in removing gases because it is not using the vacuum source. So in this first part, we explain about the what scavenging systems are, the what anesthetic gases are, and also explained about the types of anesthetic gases, the effects of this the effects of the waste anesthetic gases to the healthy workers. We also explained about the regulatory and safety measures that are there. And we also explained about how the scavenging system works, the components, the types of scavenging interface. We also explained about the types of scavenging systems, which is passive and also active. So my colleague Victor is going to proceed with the presentation. Thank you.
So I'll take you through the second part of the presentation. I'll just take you through how you can check through the systems, especially the active system that goes with a closed interface. Because it was pointed out that these systems actually use valves, the pressure relief valves, as a source of protection to both the patient as well as those working around the operating room. So firstly, to point out when there is too low vacuum, the collection bag may become too distended and the pressure relief valve opens. So the pressure relief valve actually protects the patient against so the positive pressure relief valves protects the patient against a high pressure buildup in the system. So it is important to ensure that the functionality of this, to ensure that this positive pressure relief valve is functioning correctly. So you can check its functionality by the following procedure. So firstly, you attach a circle breathing system to the anesthesia machine. Then after that, you activate the oxygen flash valve because each system has an oxygen flash valve. So you activate the valve while keeping the pop-off valve or the APO valve open. And then you observe the pressure reading on the manometer of the machine. So if the pressure reading is less than 10 centimeters of water with the collection bag fully distended, it will mean that the valve is working correctly. Otherwise, if you get any different results, let's say a result of greater than 10 centimeters of water, it means that the valve has a problem. Then going forward, you also need to check the functionality of negative pressure relief valve. So the negative pressure relief valve opens to allow ambient air to enter the system if negative pressure in the system is detected. This is because if there is negative pressure within the system, it might actually pull away the fresh gas being delivered to the patient. So it means that the patient won't be able to breathe in the anesthetic gas. So the functionality of this valve can also be checked by the following procedure. Like firstly, you also attach a breathing circuit, as well as if you attach a breathing circuit and release a bag or a collection bag. So with the APO valve open, you occlude the patient end of the circuit. Then you turn on the oxygen flow meter to the minimum setting. And after that, you apply suction to the scavenging system using a pipeline. So if the pressure reading on the manometer of the machine is between 1 and 2 centimeters of water, then the valve is working correctly. If you get readings that are out of that range, it might mean that the valve has a problem. So for the passive system, as pointed out, some just uses pipings. They just take the waste anesthetic gas directly to the atmosphere. So for systems like that, you just need to regularly check them for leakages. But for the system that use adsorption canisters, for example, we have a passive system kit on the right of the slide. So for such systems, you have to ensure that the canisters are changed depending on their weight gain over time. So the weight gain of the canisters vary from one canister model to another. So for some canisters, they might need to be changed after they have gained a weight of 50 grams, because as anesthetic gas is being collected in the canisters, the weight of the canister changes. So after a 50-gram weight gain, they have to be changed. While for others, they may need to be changed after 100 to 120 grams weight gain. However, it should be noted that it is recommended that the canisters must be changed every 12 hours of the treatment operation. So having looked at that, let's look at some of the factors that might influence your system selection. Which system should you go for, the passive system or the active system? So just to point out, the first thing that has to be considered is the maintenance expertise that you have at your facility. So, for example, the active system, as pointed out, it requires a high level of maintenance than the passive system. So if you have limited maintenance resources, you might need to procure a passive system. But if there is enough maintenance resources as well as maintenance expertise, you might procure an active system. Additionally, you have to consider the volume and type of gas being used at the facility. So it has to be noted that the passive systems can effectively scavenge halogenated inhalants, but then they do not scavenge nitrous oxide. So if there is, if the gas that is being used is nitrous oxide, it is a recommendation that you use an active system because it's the only system that can scavenge that type of gas. However, if it is halogenated inhalants that are used, for example, halogen or isoflurane, you might use passive systems or the active systems. But another thing that you have to consider is the quantity of the gas being scavenged as well. So high volumes of anesthetic gases would require active systems, while small volumes, you can use passive systems. Another thing that you might consider is the size of the facility or the operating room size as well. So for bigger facilities, let's say for facilities that has a higher number of operating rooms, let's say 4 operating rooms, you might, it is important to procure an active system because this system can also come of a central scavenging system whereby you can connect scavenging hoses from different rooms to one unit. So the central scavenging system actually collects anesthetic gases from different operating rooms and then disposes those gases. But for smaller facilities, you can procure a passive system, but as pointed out, that would also depend on the type of gas. If it's nitrous oxide, even if it's small, you have to procure an active system. So that goes for the operating room size as well. So small operating room sizes, small operating rooms, you would use passive systems as long as the gas that is being used is a halogenated inhalant, such as isoflurane. So having looked at that, let's now look at the installation requirements for the system. So first thing you have to take into consideration the location. So it is important to ensure that at your facility, each and every area that uses anesthetic gases, there has to be a scavenging system. It cannot only be the operating room, sometimes can be the dental. So you have to make sure that every area that uses anesthetic gas has a scavenging system. So for efficient operation, systems are required. Then other thing is ventilation and ducting. So the ventilation is important because in case of leakages, as talked about earlier, this would actually help in the diffusion of the anesthetic gas. So that is important to ensure that you keep the room ventilated, properly ventilated at all times. And for the ducting, we're just talking about piping. So it is important to use the correct pipe sizes as well as color codes. So the color coding for the pipes or the scavenging system, it is recommended that they have to be different from the ones used in the patient breathing system. And also for the active system, as pointed out, it might use a fan or a pump. So for the system that uses the fan, you have to use a pipe size of a larger diameter because it provides a low vacuum as compared to when you are using a system that uses a pump as a source of vacuum. So generally, the pipe sizes they range from 19 millimeters to 30 millimeters. Another thing that you have to consider is the power supply, especially for the active system which uses a pump. So it is essential to ensure a reliable power supply to keep the vacuum pump running. So it is recommended that you have to have a power backup system in case there is a power outage. Moving forward, for the active systems, it is important to ensure that there are noise control mechanisms in place, more especially for the system that use pumps. So for the system that uses vacuum pumps, the vacuum pumps can produce noise, so there is need for noise reduction mechanisms when installing the system. So this could be acoustic enclosures to maintain a quiet working environment. Finally, you also have to comply with standards. So you have to make sure that the system complies with local and international regulations, such as ISO standards as well as NFPA standards. So these standards actually govern the design, installation, and performance of anesthetic gas scavenging systems. Having looked at that, now let's look at the preventive maintenance measures of the systems. So for all systems, the scavenging interface should be inspected for any leaks or blockages. So it is important that you ensure at least weekly that you inspect the scavenging interface for any leaks or blockages. And the other thing that you have to do is that tubings should be checked for wear and tear. So if damaged, they need to be replaced. And another thing, the vacuum pump. So this is for the active system mostly. So the vacuum pump should be regularly checked to ensure that it is operating at the correct pressure. So most of the systems comes with testing equipment that you can use to ensure that the system is actually operating at the correct pressure. And for the central scavenger that I was talking about, you have to make these tests at each and every port of the scavenger. So it means if the central scavenger has 3 vacuum ports, you have to ensure that all the pressures are correct according to the manufacturer's recommendations. The other thing is that you have to verify the functionality of pressure relief valves. So this is for the system that uses pressure relief valves for protection, as I explained earlier, or an air brake. So some systems, they don't use pressure relief valves. They just use an air brake, which is connected between the patient breathing system and the scavenging system. So to the right there is a typical air brake. So at the top, there is an inlet of anesthetic gas. Then at the bottom, there is an outlet going to the disposal system. So we have to make sure that that air brake is functioning correctly and that there are no leakages on the air brake. Going forward, some systems, they have a flow regulating valve. So for those systems, you have to ensure that the air inlet to the flow regulating valve is checked for any obstructions. So the valve has a mesh disc at the bottom, as you can see. So you have to clean the mesh disc And also in some cases, they might come with an air filter element. So the air filter element should be cleaned or replaced as necessary. Then it is also important to ensure that the indicator lights and alarms are working properly. So this basically is more for the active system as well. So you just have to verify that all indicator lights and alarms are working correctly. Moving forward, as I said, so the exhauster unit should be inspected for dust accumulation. So actually, the system that use a pump, the pump is basically a compressor with a motor and an impeller fan. So you have to make sure that the exhauster unit should be inspected for dust accumulation with the motor cooling inlet, and exhaust should also be inspected for obstructions. And another thing is that filters used in the scavenging system should be cleaned. So you have to make sure that if the system uses filters, the filters should be cleaned. For example, with the active system that uses a fan, it can come with a filter. And also, just to point out, there might be another system which involves pairing the fan and an air conditioner. So this is coupled with the fan, with a filter rather. So you have to clean the filter as well. Now let's look at some of the troubleshooting tips for the scavenging systems. So the first problem, mostly these problems are for the active systems. So the first problem is that there is low or high vacuum pressure. So the possible cause to this problem is, the first one could be a malfunctioning vacuum pump. So in that case, you would need to check components of the pump, such as the motors, the seals and gaskets, as well as the impeller fan. So you need to check if they are in good condition. The other possible cause could be leakages within the system. So you just have to ensure that all connections are tight. Another possible cause could not be the system itself, but rather the APL valve. So if the APL valve is faulty, it could also impact the low or high, because it could also impact the pressure within the system. So to troubleshoot that, you just have to use the manufacturer's manual for more information on how to troubleshoot the valve or replace it. Another possible cause could be if the system has incorrect vacuum settings. So you just have to make adjustments as necessary and then verify the readings with the testing equipment that comes with the unit. The second problem that you might encounter is the system flow rate being too low and you are not able to reset it. So as I said, for the system that have a flow regulating valve, you can encounter that problem. So the possible cause could be that the flow regulating valve is not sitting. So you have to inspect the valve for correct positioning. And another possible cause could be that there is a blocked exhaust pipeline. So it means that in the exhaust, a pipeline is blocked. So you just have to check the pipeline for obstructions and then clean it or replace it as necessary if it is kinked. Moving forward, the other problem you might encounter is that the scavenger does not start. So the possible causes to this problem could be that there is a blown fuse. So you just need to check the fuse and replace it. And another possible cause could be that the fan is obstructed with jet or dust. So you just need to clean or replace the fan. And another possible problem could be inadequate voltage supply. So you have to verify that the correct voltage is supplied. And for the system that uses the pump, it could be that the motor has failed. So you just have to verify that the motor is functioning properly. If not, you have to replace the motor with the same specifications. The other problem would be that the exhauster unit, which is the pump itself, produces abnormal noise. So the possible cause to that could be that the bearings have failed or that the impeller fan is stuck. So you just have to remove the motor end cap and check the motor for freedom of rotation. Another possible cause could be the leaking connections. So you also just have to check for leaks and tighten the connections. Lastly, another problem you might encounter is the overheating of the exhauster unit. So this could be caused by obstructions of air inlet and outlet ports. So you would need to clean the air inlet and outlet ports. Similarly, if there is dust accumulation on the cooling fins, you need to blow the impeller fan. So the last part of the presentation, we'll look at the impact of the scavenging system on healthcare safety. So the first thing is that the scavenging system in place, there's enhanced occupational safety. So it protects the healthcare workers against potential long-term health hazards associated with exposure to waste anesthetic gases. And another thing is that it enhances patient safety and those allowed by improving air quality in the operating room. So this is because with the system in place, there's reduced risk of cross-contamination. So that means the patients are protected against breathing in of contaminated air. So that's all we had for you today. And reaching that extent, I will hand it over back to our host.
All right, thank you very much, our engineers, Victor Mzembe and Ethel, for quite wonderful presentation. This time is now for questions and comments. So if you have any question or comment, please raise up your hand and I'll give you a chance to speak. I see Good Luck has been raising a hand almost for the entire presentation, but please keep them raised. I'll give you a chance. So at this point, because of time, let me give this time to Good Luck Oboro to say your comment or whether to ask your question. Over to you, Good Luck. Okay, so at the beginning of the presentation, I said we'll give out a form for a survey that we're trying to get feedback from how our webinars have been for the year 2024 and how you envision them to be in the coming year of 2025. So the form has been, the link to the form has been pasted in the chat. Please take a few minutes to fill out the form and give us your feedback on how you want our webinars to go like. Another announcement from the Oxygen Alliance. We will start issuing out the certificates for the previous theme from the third quarter of 2024, where we were covering the medical imaging technology. So if you know that you attended at least 60% of our webinars, please be on the lookout to these certificates. If you, by any means or by any chance you don't get to receive your certificate, please don't hesitate to reach us by emailing us at info@oxygenalliance.org so that you can claim your certificate. There was a question in the chat. I believe our engineers, you saw that. May you please attend to it.
Okay, there's a question saying, anybody have recommendations for a cheap or affordable anesthetic gas analyzer? What can we use to measure the safe level of leak anesthetic gas cheaply? So first of all, we don't recommend any brand, but we use the anesthetic gas analyzer monitor to measure the concentration of the gas level, and it is measured in parts per million. So basically, they use the infrared absorption spectroscopy to detect the anesthetic gases. So maybe when you're looking for the monitor to use to measure the waste anesthetic gas, you need to see if the gas level is measured in parts per million. Thank you.
All right, thank you very much, Ethel. Do you have any other question or comment? All right, silence means there is none. Let me thank you, our audience, for attending today's webinar, where we were looking at the scavenging systems of anesthetic gases. Thank you very much for being an awesome audience and for making your time to attend our webinar. Until next time, it's goodbye from us.